Introduction to Algorithmic Thinking. Welcome to our first lesson. I'll be explaining the importance of algorithms in life and how you can train your mind towards designing better algorithms in the first few lessons. Algorithmic thinking is a way of getting us to a solution by identifying the individual steps that are needed, creating a set of rules called an algorithm that, if followed precisely, leads to an answer. For example, we all learn algorithms for doing multiplication at school. If you or a computer follow these rules that we are taught precisely, we can get to an answer for any multiplication problem. Algorithmic thinking allows solutions to be automated. Let's have a look at this in the context of the word searches. Now, when you try and solve a word search, what you could do is just randomly look around the grid of letters for one of the words. But this is probably not the most successful approach. What you want to do is to first identify which word you're going to look for, so breaking the problem down. If we're just looking for the algorithm or the word algorithm, we could then just randomly look around the grid for the word algorithm, but we're unlikely to find it. So what we could do is to take an algorithmic thinking approach and look for the first letter of the word algorithm, and again we could randomly look in the grid of the letters. It feels like there's a very systematic approach that we can take here, and therefore using algorithmic thinking, we should be able to create an algorithm to solve the problem. So here's an outline. Algorithm for solving the word search for every word to find in the word search. We need to check every letter in the grid if the letter in the grid equals the first letter of the word. Then for all the letters adjacent to the letter, check if the adjacent letter in the grid is equal to the second letter of the word. And if it is, for the length of the word, check all the letters in the same direction. If a letter does not match, then the word is not found. If there are no more letters to check because it's outside the bounds of the grid, then the word is not found. If all the letters match, then the word is found and we can output where the word was found. So the first thing that we're going to need to do is to think about how we can store our data. Now, if we use the concept of abstraction, we can think about what's important and what's not important in terms of the data that needs to be stored. Now, clearly the letters need to be stored and the grid is also important. Because we know which letters are connected to which other letters, but we need to be able to refer to them, and therefore we need to number them, and it would be probably the most efficient approach if we had some x or y coordinates. So when we're looking at this instance of D, for example, we know that x is 7 and y is 5. It'll make deciding which letters to check next much easier, because we can refer to them with numbers. Now, if we take the concept of abstraction just a little further, the size of the grid is not important, and in fact, even the words that we're looking for are not important, and the individual letters are also not important. The only thing we're interested in this word is that we're looking for and the letters for that word in the grid. All others are irrelevant. By taking a problem, applying decomposition and algorithmic thinking approach, we can think about how to store our data using the data structures provided by a language here. The final thing to do after creating your algorithm is to give some sensible output. It would be handy if the program told us where to found the first letter of the word and then which direction to look for the rest of the letters. So this little part of algorithm needs to be designed which tells you x and y coordinates where the first letter is found, and then where you're going backwards, going forwards, up, down or diagonally in order to find the rest of the word. And so that is how you can apply algorithmic thinking into writing a program that would solve a word search. You can apply the same approach to any program. You just need to break the problem down. You need to think about what data is important to store and what data is not important to store using abstraction, and think about the relevant data structures that you've got in your programming language. That would enable you to store the data by taking an algorithmic thinking approach. Just take it step by step and solve each individual part of the problem to create a solution that can easily scale up to solve any similar problem. Now, this skill is not easy. When you're learning programming for the first time, it does take a certain amount of experience and certainly some perseverance. You need to just keep trying and thinking logically about what you're trying to achieve and how a computer can actually achieve it. We'll talk about the usage of algorithms in computational problems in our next lesson.